Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS3492 Database Management System and the unit is Advanced Topics. The topics is Distributed Data Storage. Consider a relation R that is to be stored in the database. There are two approaches to storing this relation in the distributed database. First one is replication, then second one is the fragmentation. Replication means the system maintains several identical replicas of the relation and stores each replica at different sites. The alternative to replication is to store only one copy of a relation R. And next one is the fragmentation. Fragmentation means the system partitions the relation into several fragments and stores each fragment at a different site. These are the two important approaches for distributed data storage. Data replication. If a data relation R is replicated, a copy of a relation R is stored in two or more sites. In the most extreme case, we have full replication in which a copy is stored in every site in the system. There are a number of advantages and disadvantages to replication. First one is availability. If one of the site containing relation fails, then the relation R can be found in another site. Thus, the system can continue to process queries involving R despite the failure of one site. Next, increased parallelism. In case of where the majority of accesses of the relation result in only the reading of the relation, then several sites can process queries involving the particular relation in parallel. The more replicas of or there are, the greater chance that the needed data will be found in the site where the transaction is executing. Hence, the data replication minimizes the movement of data between sites. Increased overhead on update. That means the system must ensure that all replicas of the relation R are consistent, otherwise erroneous computations may result. Thus, whenever is updated, the update must be propagated to all sites containing replicas. The result is increased overhead. For example, in a banking system where account information is replicated in various sites, it is necessary to ensure that the balance is in a particular account agrees in all sites. Next one is the data fragmentation. If a relation R is fragmented, R is divided into number of fragments, that is R1, R2 to Rn. These fragments contain sufficient information to allow reconstruction of the original relation R. There are two different schemes for fragmenting a relation. First one is a horizontal fragmentation, then second one is a vertical fragmentation. Horizontal fragmentation splits the relation by assigning each tuple of R to one or more fragments. Vertical fragmentation splits the relation by decomposing the scheme R of relation R. In horizontal fragmentation, a relation R is partitioned into a number of subsets R1 to Rn. Each tuple of relation R must belong to at least one of the fragments so that the original relation can be reconstructed if they needed. Horizontal fragmentation is usually used to keep tuples at all the sites where they are used the most to minimize data transfer. In general, horizontal fragment can be defined as a selection on the global relation R. Next one is the transparency. The user of distributed database system should not be required to know where the particular data are physically located, nor how the data can be accessed at the specific local site. This characteristic is called data transparency. This can take several forms. First one is the fragmentation transparency, then second one is the replication transparency, then third one is the location transparency. Fragmentation transparency: users are not required to know how a relation has been fragmentation. This is known as fragmentation transparency. Replication transparency means users view each data object as logically unique. The distributor may replicate an object to increase either system performance or data availability. User does not know how to be concerned on what data object have been replicated and where replicas can be have been placed. This is known as replication transparency. Next one is the location transparency. Users are not required to know the physical location of the data. The distributed database should be able to find any data as long as the data identifier is supplied by the user transaction. Distributed transaction. There are two types of transaction that we need to consider. First one is a local transaction, then second one is a global. Local transactions are those that access and update the particular data in only one local database. Global means global transactions are that access and update data in several local databases. Next one is the system structure of the database. Distributed transaction. Each site has its own local transaction manager, whose function is to ensure the asset properties of those transactions that execute at the site. The various transaction managers cooperate to execute the general global transaction. To understand how such a manager can be implemented, consider an abstract model of the transaction system in which each site contains two subsystems. First one is the transaction manager, then second one is the transaction coordinator. Transaction manager manages the execution of those transactions that access data stored in a local site. The transaction coordinator coordinates the execution of various transactions, both local and global, initiated at each site. Here in this figure, the transaction coordinator is defined referred as TC, and transaction manager is represented as TM. Here the TC, that means the transaction coordinator, coordinates all the various transactions performed by that is managed by the transaction manager. Next, system failure modes. The system failures occurred in the following modes. There are first one is a failure of the site. Then second one is a loss of messages. Then third failure mode is a failure of the communication link. Then next one is a network partition. These are the some of the system failure mode occur in the distributed database system.